Earth, our blue planet, oceans everywhere you see, vast, deep, mysterious. They hold so much life, more water than land, you know. It's a water world, our home. Two giants stand out clearly, the Pacific Ocean so wide, the Atlantic Ocean so long. Do these colossal bodies of water actually meet? Do their waters mingle and dance, or do they stay separate like shy neighbors? Ocean mixing affects our weather patterns. It shapes our climate across the globe. So let's dive in, shall we, together into the heart of the ocean. So, where do these mighty oceans greet each other? Think of the bottom of South America, a wild, stormy place full of drama. Cape Horn, they call it, a legendary spot. Here the waters churn with immense power. The Pacific and Atlantic touch they embrace. It's a dramatic meeting point indeed, a true spectacle of nature's raw power. Then there's the Drake Passage, a famous channel, a wide stretch of often turbulent water between South America's southernmost tip and Antarctica. Here too, the great oceans connect directly. Waters flow between them, a constant exchange. Imagine the currents moving silently there, connecting worlds unseen by most. And let's not forget the Arctic Ocean, way up north. At the top of our world, it acts like a cold, icy cap for our planet, connecting the northern reaches of the Pacific and the northern expanses of the Atlantic. Waters from both these giants flow into it. These meeting zones aren't sharp, defined lines. They are broad areas of dynamic interaction. What governs this mixing, or sometimes its absence? It's about water properties, you see, quite simply. One key factor is density, a fundamental concept. How heavy the water is for its given volume. Denser water naturally sinks downwards. Lighter water prefers to float on top. Simple physics at play in the grand oceans. Temperature plays a very big part in this. Warm water is usually less dense, you know. It likes to stay on the surface, basking. Cold water, conversely, is typically denser. It tends to sink down into the deep. This creates distinct layers in the ocean, like a beautifully layered cake with different strata. This layering effect is called the thermocline. Salinity, or saltiness, matters a great deal too. More salt means the water becomes denser. Less salt means the water is lighter, less heavy. This salt-based layering is known as the halocline, another crucial factor in this watery equation. These differences in temperature and in salinity, they create distinct water masses within the ocean. Sometimes these different masses resist mixing easily, but eventually, slowly, with persistence, they do mix. Current affairs, the ocean's conveyor belts. Imagine giant flowing rivers within the oceans. These are the powerful ocean currents, my friends. They are incredible movers of massive water volumes. Huge quantities, constantly flowing, never resting. Some of these currents are warm, some are cold. They act like massive conveyor belts for the planet, transporting water across the entire globe tirelessly. Day and night they work, shaping our world. The Antarctic circumpolar current is one such giant. It flows majestically around Antarctica unimpeded by land. It directly connects the Pacific, Atlantic and Indian Oceans. A true global connector, this remarkable current is, it's the largest and strongest ocean current on Earth. A mighty force of nature, indeed, a true titan. It plays a significant role helping waters mingle. Imagine its power circling the southern continent. What powers these immense currents, you might wonder? The wind blowing across the ocean surface is a major driver. The Earth's rotation also plays a crucial role. The Coriolis effect, it's called in science. It deflects moving water, a fascinating phenomenon. These currents don't just move water aimlessly. They transport enormous amounts of heat around the planet. Debunking the wall misconceptions and reality. You might have seen some intriguing pictures online, or perhaps videos shared widely on social media, showing what appears to be a sharp line in the ocean. Two different colors of water, side by side. Not mixing, it seems, almost like a boundary, like an invisible wall stands firmly between them. Is this actual proof that oceans don't mix? Let's investigate this popular claim with a scientific eye. Science demands evidence and careful observation always. Often these captivating images show something else entirely. Perhaps it's where a muddy river meets the clear sea. The river water is full of suspended sediment, making it opaque. The ocean water is clearer, more transparent, so you see a temporary line, a visible contrast, or it could be glacial meltwater flowing out. Fresh, light, and often a distinctly different color, meeting the salty, denser, and darker ocean water. These are Interfaces, not impenetrable barriers. These are usually local phenomena, not global rules. Temporary boundaries, not permanent, unyielding walls. The waters might look distinct for a little while, but given enough time, and with the ocean's constant energy, mixing does happen. Slowly, but surely it does. A connected world. Why? Ocean mixing matters. So do the Pacific and Atlantic Oceans truly mix? The answer is a resounding, unequivocal yes. They do. Absolutely, they mix without any doubt. It's not always a fast process, mind you. It's not always immediately obvious to our eyes. But the mixing is constant. It's ongoing. It's a fundamental process of our planet, happening on a grand planetary scale always. This mixing is incredibly important for us all. It's absolutely vital for our planet's overall health. Think of global climate regulation, a critical function. Oceans absorb and release vast amounts of heat. Mixing helps distribute this heat energy effectively, from the warm, sun-drenched tropics to the cold poles, like a giant natural thermostat for our Earth, keeping things in a delicate, life-sustaining balance. And what about the teeming life in the sea? Ocean mixing brings essential nutrients up to the surface, from the deep, dark, mysterious depths of the ocean to the sunlit surface waters where life thrives, where tiny plants, the phytoplankton, can grow. They are the very base of the marine food web, supporting all ocean creatures, both big and small. Mixing, therefore, means life and abundance. If you like this video, give a like, comment, share, and subscribe to our channel for more amazing content.